is that this is the important stuff you need to know. A is the distance from center to vertex. B is the distance from center to co-vertex. And then C was the distance from center to focus. That doesn't change for either the ellipse or the hyperbola. What was a little bit different was the p-value when you're dealing with the hyperbola, or excuse me, with the parabola, but that wasn't so scary. What happens here is that you always need to worry about finding centers. Centers are always going to occur at the midpoint of a vertex, a midpoint of a focus, the midpoint of a covertex. Always, always, always. Okay? So here's what happens. Yeah,
When do you have center then?
next Friday then. So if we're looking at 16 to start out with, or 17, excuse me. The first thing I'm going to do is rough sketch it, so that way I have an idea of if it's opening up and down or if it's opening left and right. From there, I can then find everything. And that's kind of the trick to all of these types of problems. So it's an ellipse, vertex at 2, -3, 2, and 6. Bless you. So those are my vertices, so right off the bat I can tell that it's opening up and down. My focus is at 2 and 0, and 2 and 3. I know it's going to look something like that. Well, because you didn't have the right mode, so yeah, it's no big deal. Now at this point, what we're going to find out first is what H and K is. Your H and K is the center. Since it's opening up and down, the value of H is going to be the exact same thing as everything else on that vertical line, 2. Now I just got to figure out what K is. In this case, it's going to be the halfway point between 6 and -3. Yes, sir?
Is it halfway between the ball guy?
Yes.
It's
Or
halfway between both, right?
it's halfway between either one of them. It's halfway, the center will always be occurring at the halfway point of the vertex, the halfway point of a focus, and the halfway point of a covertex. It doesn't matter which one you use. You will get the same point. Yep. So here I'll do -3 and 6 is 3. So half of that is 1.5. There's my H and K. Okay. So now I plot that to give myself an idea of what's going on. I'm going to figure out what A is. A is the distance from center to vertex. 1.5 to 6. How far apart is that? Very good. It's 4.5. My C value is the distance from the center to the focus. 1.5. Very good. I do not know the B value, but I do know what the generic form of the equation looks like. We have an ellipse. It's opening up and down. Excuse me. I know it's opening up and down, so that means the a squared term will be underneath the y. Now here's the trick. An ellipse has a plus symbol between the two fractions. Do you agree?
Yes.
Therefore, when you set up the a squared, b squared equals c squared, what goes here? Minus. It's the opposite. It's the opposite. With the hyperbola, it was a plus sign between the two fractions. Or excuse me, with the hyperbola it was a minus sign, so then it was a plus sign with the a squared plus b squared. They're opposites. If you do a couple of these, you'll start to remember that. So all I have to worry about here now is filling it in. 4.5 squared minus 1.5 squared is b squared. All I did there was move the c squared over, move the b squared to the other side as well at the same time. When I do that, I think you get 18.
Yeah.
Do I need to know what b is? Do I have to plot it anywhere? No, I'm just writing the equation. So I found out what b squared was. I do need to know what a squared is, though. Isn't it, I think it's 20.25, if I'm not mistaken. I now know everything that I need to know to write this equation. X minus 2, quantity squared, over 18, plus y minus 1.5, quantity squared, over 20 1/4, equals 1. And that's it. When you're setting these things up, you always want to do a rough sketch, figure out your center, and work your way out of it. And it's nothing more than counting, more often than not. You don't need to worry about some crazy stuff. And here you notice our center happened to be at a half z. You can figure that out. It's not that bad. 1 1/2. What? What?
A zombie is an official animal. It's a donkey. It looks weird.
A zonkey?
Yep, zombie.
Why do they call it a zebra?
Because it's
Because it is
spelled like
Deborah.
Deborah.
Yeah. Yeah, so everybody's named Debbie that we feel bad for. A zonkey.
And then if your name is Zombie, then you will.
So it's a.
Elizabeth has
So is it a striped jackass?
only the legs have two lines. It's kind of weird. Look it up though.
I will.
Yeah, what more did it
Elizabeth
say?
has met a zombie.
Wow.
What's that? You found one and said. Oh, you did?
Yeah, that's what it is.
Nice.
What?
Let's try another one like that. Let's try another one like that. Again, we're going to build off of this with another ellipse problem before we get to the hyperbola. No. That's Photoshop. Really? I guess. Huh, interesting. All right, so we're going to write the equation again. This ellipse has foci at 3, 5, 3, -1, and vertices at 3, 6, and 3, -2. It's really nice when they tell you what you're graphing, because you have, a better chance of being right than what you're doing. Yes, sir.
Did they ever not tell you?
Yes, sir. We'll get to that here in a little bit. So, when we plot this one out, again, I have vertex at 3, 6, and 3, -2. From that alone, you should be able to tell this is going to be going up and down. Everybody agree on that? All right. Plot in your foci, 3, -1, and 3, 5. So I know it's moving up and down. As soon as I know that it's going up and down, I'm again going to look at my calculator to get the generic form of the equation. I know it's going to be this one. The a squared term is going to go under y. Okay? I know that because the diagram on the calculator showed me that. Okay? So now I'm going to figure out what h and k is. I know that h and k, I know one of these values right now. Which one do I know? Which is it? Which one? What is the value of h? Good. I know it has to be 3. Because they're all on the same line. What's that? Now I just have to find the midpoint. So what is 6 plus -2? What's half of that? Finding the center should never be difficult. So my center is at 3, 2. How far apart is 3, 2 from 3, 6?
4.
It's 4. Center to that is A, so A is 4. Center to the focus is how much? 3. It's an ellipse, which means it's plus between it, so it's going to be a squared minus b squared. So what's 4 squared? 16 minus 9 is b squared. Is everybody okay with me moving those literal equations around before I write it down, before I do it?
Wait, I thought. Oh, wait.
Yeah.
Okay, the really simple thing here that I didn't catch, when you got the center,
Yeah.
you subtracted what from what from where?
Oh, how to find the
Yeah, you
center?
said it really quick. and I-
Okay. What I did here is that the center is going to occur on the same vertical line there, so it's the x value has to be 3.
Okay.
Then I just have to find the halfway point of the y's. 6 and negative 2 is 4. What's half of that?
Oh.
2. So we're going to find the midpoint. Basically, you're just using the midpoint formula, but I've got the same x coordinate for both.
You
So
just add the y's and divide it.
yes, ma'am. Okay. So now I get 7 is b squared, and a squared was 16. You now know everything you need to know to fill in the rest. X minus 3 quantity squared over 7 plus y minus 2 quantity squared over 16 is 1.
So no matter what x and y is, it always comes.
It should, yes. Stop whistling, please. Thank you. Okay? All right, well, let's get funky.
Wow, man, you're so
Hey, Willis. You are not.
Sorry, Willis and I were jamming out there.
Still hurts a little bit. Yeah, Mike hit a ball at my back yesterday.
No.
Why'd you hit him in the head?
A baseball. I actually had a helmet on.
You're legitimately.
All right, so we've got a hyperbola. The hyperbola takes a little bit more work to go through. What do you think the first thing we're going to do is?
Draw it out.
Yeah, draw it out, exactly. Draw it out to get the idea of what this should look like. You all right there?
Wait, this isn't Willis. This is a hyperbola.
Says so.
Oh.
Vertices at 5, 0 and 5, negative 4. Foci at 5, 2 and 5, negative 6. What direction is this opening?
Up and down.
Very good. It's opening up and down. Remember, vertex always opens towards the focus. Okay. Now I go to my calculator.
This is. So it's.
This, when we're dealing with the hyperbola, since it's opening up and down, that just means that the y squared part comes first. Okay? Again, we need to find the halfway point of the vertices. We all agree that the h and k here for the center, the h value is going to be what? Good. Now, to find k, all I have to do is take 0 plus negative 4.
That would be
Negative 4. What's half of that? 2. Very good. So my h and k is at 5, negative 2.
Wait, so is that between the foci or the foci?
Yes.
The foci?
Yeah.
Oh, it's the midpoint of either one of them.
Oh.
It's the midpoint of all three of those important points. It will be the midpoint. It has
the
to.
alternate.
Okay? Now, all I have to do is figure out the a values. Well, from center to vertex is 2. So a is 2. That means a squared is 4. Center to focus, in this case, is how much? 4. So that means that c squared is 16. Again, all I'm doing is just counting. I'm not trying to do anything real fancy or crazy here. Yeah.
Where do you get the A?
A is the center to the vertex. B is the center to the co-vertex. C is center to focus.
Oh, right.
Okay. Now, with the hyperbola, what's that symbol?
Minus.
Subtraction. So therefore, when you set up your a squared and your b squared, what goes between them? Good. So we have 4 plus something is 16. B squared is not 20, it's 12. Okay? Now I can do everything. Y plus 2, quantity squared, over 16. Oops, sorry. 4. Sorry, I was looking at the wrong one.
Wait, when did you?
Yeah, I wrote it. Minus x minus 5 quantity squared over 12 was 1. What's that? When you're writing about, when you know a set of ordered pairs and you know what you're working with, it's relatively easy. It's when you don't. No, because remember, your vertex is always opening to the focus. Your curve is always going to eat the focus. Think of packet. It has to tell you that. If you're only given sets of ordered pairs, it has to tell you this. If you don't know that, I'll show you in a second. Yes, sir.
So when you add a squared, b squared, b squared.
Subtract.
Wait, so don't we add to this one?
Yes. A squared plus b squared is c squared. 4 plus b squared is 16. I had to subtract the 4 over to get b squared by itself.
Oh,
Well,
okay.
wait, even if you know that it was a hyperbola and it says the foci is like that way.
You should know that, yes. And like what she's saying here, guys, as long as you know that your vertex is here and that's your focus, you should know that your vertex opens to focus, always. No matter what the curve is. Your curve is always opening to the focus. Always, always, always. So you really don't need to know this. Thank you. Okay. All right, let's see what happens when it hits the fan.
Oh.
It blows up. The fan blows up. What?
6 p.m. today. Oh.
Now we don't know what's going on.
Getting out?
I have a conic that's written in a quadratic form.
Blew my mind.
I'm done.
I can't even.
I'll see you all next week.
Ladies and gentlemen, hold on. This takes a little while to get through. It is a bit of a pain. Bear with me. You're going to have to remember some stuff that you've forgotten. We have the equation 2x squared plus y squared minus 4x minus 4 equals 0. Yes, sir?
Like, separate the
We are, yes.
and then do the.
Yep, that's where we're headed. So here's what we do. Anytime that they are written out in this, what we're going to call quadratic state, you want to get it into this standard form. You want it to get it to look like one of the ways that you have on the equations already in your calculator. So that way you know what it's going to look like, and then eventually graph it. Because we haven't even graphed a shifted one yet from an equation, even though you kind of know how to do it. So let's take a look at this. What I want to do first of all is for every one of these problems, I'm always going to move my constant to the other side. I do that first. Which one doesn't have a variable? Y squared has a y squared. It is not a constant. 4. I'm also going to group together the x's and the y's and all that stuff into the same families. So I get 2x squared minus 4x plus y squared is 4. Okay. Now, what you want to notice is that all of your generic forms of conics with shifts were all written as junk squared. They're all written as as junk squared, which means I need to make a perfect square out of these, which means I have to complete the square. Okay. Yes, you can. You did it 3 months ago.
With the same.
I did a lot of things 3 months ago.
I didn't teach you guys how to add and subtract, though, did I? Still know how to do that?
4.
Yeah, that's common sense.
Here's what happens.
What?
Mr. Simmons on this thing.
Mine doesn't know how to do
In order to complete the square, one of the things you had to have done first was that your leading term coefficient always had to be 1. Right now, it's a 2. It's 2x squared, which means I have to factor out a 2 from the x squared and the x. So I get the following. By factoring out the 2 on the left-hand side, when I go to complete the square, hold on. When I go to complete the square, you take half of b. What's half of -2? Square it. You add that to both sides. But I want to show you something. Notice how I factored out a 2 here? So if I distributed that back in, I'd have to multiply that by 2, correct? So I have to put a 2 over here, 2 times 1. Whenever you take a GCF out on the left-hand side, automatically put that GCF here with parentheses to remind yourself to put it over there. We do a couple of these, you'll remember it each time. Okay. You have just completed the square. You took half of b and you squared it. Therefore, this new term for junk squared will be x minus 1. Remember, the trick was half of b was your term. What's 4 plus 2 times 1? 6. You're almost done. You can probably tell right now that you're either going to have an ellipse or a circle. Why can you tell that? You know, because there's a plus sign.
That was my next guess.
Now, yeah, they're both squared, but circle, this isn't going to be a circle because you've got this 2 out here, which means you're going to have an ellipse. In order to get the equation of an ellipse, you divide everything by that. Because remember, it has to equal 1. And there's your answer. It gets you into the ellipse after you do all the completing of the square. Because in your calculator, you've got the equations of what the standard form is going to look like. You need to be able to manipulate that equation to get there. Because now you can look at that and say that your h and k is what?
H is 1.
1 and 0, very good. So my h and k is 1 and 0. And if I'm looking at my generic form of the equation, I will be able to figure out what a squared is, what b squared is, and I can plot it from there. In this example, I'd have to do some square root of 3, square root of 6, and mark off some decimal equivalencies. It's not that big of a deal, but for right now, today especially, I'm just focusing on getting to the equation. We'll worry about the graphing part later. That's the easy part. This is the pain in the butt stuff. It's kind of like the donkey and the zebra thing.
Oh,
Sorry, I'm trying to reference something. It doesn't work.
yeah, but
All right, let's do another one. Four x squared minus 9y squared plus 32x minus 144y minus 548 equals 0. Sounds like a fun problem. What do you think the first thing you're going to do is? Good. First thing you do is add the 548 to the other side. And while I do that, is it okay to regroup things with the x's together and the y's together right off the bat?
yeah.
Might as well.
Oh, this,
Or this what?
nothing.
Go ahead, say it.
I was just trying to factor out 4, and I realized that it was 9y, so you can't do that.
You can't do that yet. Because here's what's happening. You're on the right track of wanting to factor, but as soon now if you look at it, Michael, you've got the x's together, you're going to group them here. Yeah.
How will the other one be factor out to like just from the left part?
They were just moved around differently. I'm still going to factor out a 4 here
Yeah, but like how could you do it like using the y squared?
because I'm going to factor something here too. I'm going to make 2 terms. That's why I'm splitting these up into 2 spots. By splitting them up, because I'll make 2 perfect squares, which means I'm going to have to add on 2 things on the other side. So this first grouping, I'm going to factor out the 4, and I have x squared plus 8x plus blank,
Why aren't you factoring out
because I'm completing the square.
the
I'm not taking GCFs, I'm just completing the square. Factor out the -9, same idea, y squared plus 16y plus blank equals. Again, the reason I took out the -9 is because it said -9y squared. I'll take the -9 out, it works out just the same.
Oh, we're doing both of them at the same
Yep.
time?
So on the right-hand side of the equation, we're left with 548 plus 4 times something minus 9 times something. I'm just putting those placeholders in because I'm still going to complete the square. All right? So right now, we've grouped everything together. We took out the leading term coefficient, took out a 4, took out a -9. Excuse me. The next step I have left now is to work with b. What's half of 8? 4. What's 4 squared?
16.
So I'm adding half of b and square it, add it to both sides. Excuse me. So I have 4 times the quantity, x plus 4 squared. Okay. Go to the 16. What's half of 16?
8.
Square it.
64.
Add it to both sides.
big number.
Don't do this by hand. Use your calculator. Yeah, Shay. Well, what stuff?
Okay, so you put in the 16 and then what do you do to get the x plus 4 squared?
What I'm doing here is, remember, I'm creating a perfect square. You take half of 8, you get 4, you square it, you add it to both sides. That half of 8 is that term. What times what 16 to add together to get 8? That's the same number, 4.
Okay, so then that all just goes away.
You're creating a perfect square because now I'm going to have an x minus h, a y minus k, and so on. Okay. What did you get on the right-hand side? Very good. What do you think you do from there? Divide everything by 36. It's a hyperbola. What direction is it going? Remember, look at your graphing calculator. X squared came first, so I know that this graph is going to go left and right. I also know where my center is.
Well, it was a hyperbola.
Yeah. And the reason it's a hyperbola is because it's got a subtraction symbol between the two. You probably would have been able to figure out that it was a hyperbola a long time ago, but you couldn't do the rest of it. What is it? Good. Oh, you know what? No, let's do this. So right now you know this. Our center is at -4, negative 8. A squared is 9. B squared is 4. Everybody okay with that? A is 3. B is plus or minus 2. C is plus or minus 3. Everybody okay with that? So when you go to plot this, where do you think you're going to start? What is that middle point? The center. What is the center in this case? Go to negative 4, negative 8.
Where did that come from? Oh.
Negative 4, negative 8. That negative 4, negative 8 came from our h and k. All right? Now, when you're graphing a hyperbola, you know that it's going left and right. So that means that the distance, that a value, is going to be from the center to what? Vertex. So that means I move right and left from this value here, right 3, left 3. Negative 1. 7. Okay? What's that? The B value was that covertex. Which means I go up and down too. What did you do from there? Make the rectangle. What does every hyperbola have? It's got horizontal asymptotes. Oh, well, that's point spot right there. Or slant asymptotes. You're right. Yeah, slant asymptotes. Sorry about that. And then it's a matter of figuring out your, plotting out your focus. In a hyperbola, was it a squared plus b squared, or is it a squared minus b squared? Good. So what is 9 plus 4? The decimal equivalent of the square root of 13 is a little bit more than 3. Okay, so if this much was 2, here's 3-ish. 1, 2, 3-ish. Basically, it's looking like this then. You agree? We will be writing the equation of the line of the slant asymptote next week. You already know how to get the slope of it. It was either a over b or b over a, depending upon which direction it was going. You already know a point that goes through that line, the center. The center. So you're just using point slope. Yeah. It's really not that tough. One of the reasons why I want to get you guys to start writing the equation of that slant asymptote is that you use that a lot more when you get to pre-calc, when you guys are doing it. Just kind of getting you in the habit of doing it. Okay? Again, starting out, it looks like it's god-awful. But as you get going to it, it's just a lot of completing the square. Okay? Well, let's see. I knew there was another one I wanted to do real quick.
Straight away.
Yeah, it is.
All right, let's try this one.
Doing another one?
Yeah, might as well. We got time.
My brain's fried.
Yeah, you'll be okay. To be honest with you, you guys could probably look at it right now and tell whether or not it's going to be one or another. I'm not there anymore. So we start this one out. Which one of the shapes, there's actually two shapes you can cross off. What's the most obvious one you can not, this will not be? Why won't it be a hyperbola? Because there's a plus sign there. between the x squared and the y squared. What else can you tell it's not going to be? Why won't it be a parabola? Because think about the parabola. How many squared terms are in a parabola? One. Either an x squared or a y squared. Here I've got x squared and y squared. I know it's not going to be a hyperbola because there's a plus sign. It's either going to be a circle or an ellipse. Okay? So let's walk through it. 9x squared plus 36x plus 4y squared minus 24y equals negative 36. Okay? Take out the 9 from the x squared stuff. You have x squared plus 4x plus blank. So it means over here I'll have a negative 36 plus 9 times something.
Oh, negative.
Yeah, it's negative 36 because I moved it over.
I know, but I didn't put negative signs.
Don't do that. The next group, take out the 4. You have y squared minus 6y plus blank. So I have to remember to put in a plus 4 times something. And now it's a matter of completing the square. What's half of 4? Square it. So you add 4 to both sides. So my term on the left will be 9 times the quantity x plus 2 squared. Half of negative 6, square it. So here I have y minus 3 quantity squared. And what do you got on the right hand side?
Negative 36.
You have negative 36 plus 36 plus 36. You get 36.
Is that y minus 3?
What's that?
Is that y minus 3?
Yes, it's y minus 3 because half of b here is negative 6 over 2, so you get negative 3. That's why it goes there. Okay. What's that? What's half of b? There's your term.
You just do that.
Then you square it to add it to both sides. Half of b always goes in the parentheses for the junk square. Always, always, always. Okay.
And it's always x or y's. Correct.
So now when you divide everything out by 36, you get x plus 2 quantity squared over 4, y minus 3. Is that an ellipse or is that a circle? It's an ellipse. If a and b were the same, it would have been a circle. Yes, sir.
So you get to that point, you got your calculator, and you're like, I don't know what graph it is.
That's why you have a calculator.
That's why, okay.
All right. Like I told you guys, I'm not taking those away from you, but you still have to know how to do all this.
Yeah. But if we get here,
Yeah.
Really?
Because now you know what your h and k is, what your a squared and your b squared is. It's a matter of walking out to graph.
Question.
Yes, sir.
For the test for the test of this chapter, would we have an identification problem with that on calculator?
No, y'all not take it away from you. Do those. Do not do 58. Do not worry about starting your graphs yet.
no graph.
So wait until I don't graph it?
What I want you to do is get them into standard form.
No graph.
I think getting them into standard form is enough for right now. If you want to start graphing them, try it, go for it. At least start labeling them out, because it can get messy, especially with some of the weird roots that you can get, okay? So for right now, I'm okay with let's just getting them into standard form. The test is a week from today. We only have to finish up a little bit of this stuff as far as the graphing is concerned, as well as we're going to do some systems of this stuff, which is actually pretty easy. So we got plenty of time to get through. Yes, sir. At most, if you want to start labeling what your H and K is, you know, A equals, B equals, we'll go through the graph. If you feel confident you want to try graphing a couple of them, go for it. Give it a try. We'll check them and we're going to work through those then on Monday. Okay? The whole idea here is making sure you know how to complete the square. Lots and lots and lots to complete the square.
You want it?
No, thank you.
I don't want it.